130 kilogram block is suspended from a spring. Okay, let us draw that block. This is the spring, and there is a 0.113 kilogram block. When a small pebble of mass 27 grams. Okay, there is a small pebble of 27 grams or 0.027 kilograms. Place on the block, the spring stretch an additional 4.5 centimeters. So this spring here stretched additional, so this x here is additional. This x is because, that is 4.5 centimeters, because the presence of this mass here, or also I say the weight. Okay, with the pebble on the block oscillated amplitude of 30 centimeters, so find the, so we just place it, will go up and down, up and down, up and down, up and down. Find the maximum amplitude of the oscillation at which the pebble will remain in contact with the block. Okay, this is the, how do you say that, multifaceted problem. Okay, first let us find K, that spring constant. But we will need that for sure. So this is the force. In this case, this is the gravitational force, or you could say that this is the weight. So 0.027 kilograms times 9.81 meters per second square. That is the weight of the object, of this pebble here. And this pebble caused the spring to stretch how much? This much. And this much. Minus, plus, doesn't matter. We are interested in numbers, not in plus or minuses and so on. So we don't need this minus here or this one here, but doesn't matter. So because of the presence of this mass, it stretched this much. And this is the force for the spring. Minus, it's because when x is getting larger, the force is getting larger too. Well, no? That's right. Okay, why is that minus here? Sometimes. Okay, I will just place here plus, and we will cure ourselves from many problems. Why is that minus in the equation sometimes? You count x from here, 1, 2, 3, 4, 5, but when you stretch spring in this direction, force of the spring is directed in this direction. So force is opposite to the increase of x. Not increase in spring x, but increase in the, how do you call it, in axis, in numbers that are rated in axis. So this is not very important now. Why am I talking about that? God knows. So it doesn't matter this part, you just forget for time being. Okay, from here, spring constant is this much, and that is important, that is what we need. So now is the question, how much do we need, how much can we find the maximum amplitude? Okay, what is maximum amplitude? In other words, what is the maximum distance that we can stretch the spring? So you have spring here, and you have some weight here and pebble here. If you take this mass and just a little bit nudge it downwards and let it go, this will go up and down with no problems. This will stay here. But if you take this mass with your hand and stretch it all the way up to here, and you let it go, what will happen with the pebble? It will fly off. Of course it will. What are the conditions for the pebble to stay here? What are the conditions? So this mass will go up and down, of course. When it's maximum downwards, or better, I will say when you squeeze this spring maximally upwards and then let go. At what condition this ball will just stay to hover in the air, let's say, for a moment, and then start to fall? Well, when this acceleration of this mass is larger than the gravitational acceleration, this ball will fall off. in any other way, ball will stay there. So if in any case this acceleration is smaller than this gravitational acceleration, ball will remain on it. But at the point when this acceleration of this mass of this block becomes larger than the gravitational acceleration, this smaller pebble will fall off. It will not fall off when this block accelerates upwards, but it will fall off when this block can come to here and accelerate downwards with the acceleration greater than g. And there is an acceleration downwards induced by a spring. Surpass gravitational pebble will detach. That's that. And that is the equation. So you could punch in the number, do it yourself, or for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.